Good morning, students. This is for PharmD students of Sri Krishna College of Pharmaceutical Sciences, which we have seen in the class the continuation for the tropane alkaloids. Now we have to see about indole alkaloids. We have seen in the class, but the students are instructed to listen to the class whenever you get the opportunity to in the home, so that it will revise your subject knowledge and it will be helpful for your examination point of view. So PharmD students, this one is about indole alkaloids, and I have taken only two examples. There are many, and in some alkaloids I used to take only one. In this I have taken two because of importance of that two, vinca and especially Raulfia. So in indole alkaloids, you can see the structure of indole, a 6-membered ring and a 5-membered ring with nitrogen. This structure is very common, which you know that 6 and 5. You might have seen this structure even in purine derivatives. When you are studying about adenine, guanine, cytosine in your physiology, and in other chemistry also you might have come across in heterocyclic ring structure, bicyclic. So in that 6-membered and 5-membered with nitrogen, as shown in the picture, you can see very clearly A and B I have given a substitution of CH3 in the nitrogen, how it is N substituted methyl groups most of the time in the structure, and other structures will be joined with this indole structure for secondary metabolites in plants. Catranthus roseus. As I told in the class, it's necessary for the students to pronounce the biological source or botanical source of the plants which you are studying. Repeatedly you have to pronounce, or you have to teach your colleagues. You have to make yourself comfortable by means of telling with your classmates, or teaching your classmates, or sharing with your classmates, so that it will be helpful for you to study more. This is the plant even in the classroom. Some of the students who have explained, immediately they told, what's the name of this? They told, it's available in our home, it's called Nitya Kalyani, they told very clearly. This vinca is an ornamental plant, but it has medicinal use. Synonym Vinca rosaceae, Pervinca rosaceae, Len, Gatru, Lachnide rosaceae, Rich X splotch, Amocalis rosaceae, L, Lin, small. The students have to at least remember the Vinca rosaceae, Lin. The definition: Catranthus roseus, commonly known as the bright eyes, Cape Periwinkle, graveyard plant, Madagascar periwinkle, you can say, old maid pink periwinkle, rose periwinkle or periwinkle, you can say VW silence, family Apocynaceae. It is native and endemic to Madagascar, but grow elsewhere as an ornamental and medicinal plant. It was formerly included in the genus Vinca as Vinca rosaceae or rosaceae. Chemical constituents: vinblastin and vincrestin. Chemotherapy medication, anti-cancer, used in the treatment of several types of cancer, are found in the plant and are biosynthesized from the coupling of alkaloids, catranthine and vendolin. So catranthine and vendolin together forms vincristine and vinblastine. Vincristine, vinblastine are isomers. Their structural formula is similar. Only they are just have an isomeric form. The newer semi-synthetic chemotherapeutic agent Vinorelbine, used in the treatment of non-small cell lung cancer, can be prepared either from vendolin and catranthine. You should know that the importance of this plant constituents. Even the most used Vinorelbine, the drug for chemotherapeutic agent, is prepared from the natural source of vendolin and catranthine, or from the vinca alkaloids, leurosin, in the both cases via anhydrovinblastine. Rocinidin is an anthocyanidin pigment found in the flowers of Catranthus roseus. You can see the chemical structure, catranthine, which has an indole basic structure with an octane. You can see the cyclic ring with nitrogen and a 6-membered ring and a OH, and then below the plane and a CH3 group. Catranthine and vendolin, you can see the structure, how they both are joined together, and they give vincristine and vinblastine by means of a small change in their substitution in the R position of the nitrogen of the indole of the vendolin structure. Methyl group is present means vinblastine, and aldehyde group CHO group is present in vincristine. Vincristine and vinblastine are presence of methyl group and their formaldehyde group or aldehyde group. Both of them are dextrorotative, that's why we put positive. And the structural formula, as I told in the previous, they told the structure formula is similar, but they are not similar. They have a small substitutional difference, methyl and aldehyde group. That students should remember about vincristine and vinblastine. They are formed from catranthine and vendolin. Uses: the species has long been cultivated for herbal medicine and as an ornamental plant. In Ayurveda, Indian traditional medicine, the extract of its root and shoot would poisonous were used ancient several diseases, against several diseases. In traditional Chinese medicine, extracts from it have been used against numerous diseases including diabetes, malaria, and Hodgkin's lymphoma. Hodgkin's lymphoma, as a PharmD student, you should know that what is Hodgkin's lymphoma. Whenever we come across any pharmacological, therapeutical application, a pharmacological application, then you should know the disease and as well as the application detailedly. The lymph nodes are getting cancer development, proliferate developments causes Hodgkin's lymphoma. Many of the vinca alkaloids were first isolated from Catranthus roseus, including vincristine, vinblastine, used in the treatment of leukemia and Hodgkin's lymphoma. Catranthus roseus can be extremely toxic if consumed orally by humans. Chemical test answer all general tests for alkaloids that which you know that about drag and draft, Wagers, Haggers and Wagner's picric acid test. These are all tests they will answer. Adulterants and allied substituents over Catranthus species such as Catranthus longifolius, Catranthus trichophilus, Catranthus lancius are known to contain Vendolin type alkaloids. Now we are coming to Rauwolfia serpentina, Apocynaceae, the second drug which we want to discuss, even the microscopy and macroscopy of this drug, which is available in our lab, and you are undergoing the experiment in the lab also. So Rauwolfia serpentina, why it is called serpentina, serpent. It looks like snake, the roots. We are using the roots, underground roots. This is a plant, but we are not using the shoot system for our medicinal purpose. Definition: Rauwolfia contains of the dried rhizome and the root of Rauwolfia serpentina. A small shrub, as shown in the picture, found in India, Pakistan, Java and Thailand. Common name Rauwolfia, Indian snake root. Cultivation: it grows spontaneously in tropical forest, temperature 10 degrees centigrade to 40 degrees centigrade, which are humid in summer at an altitude up to about 1200 meters. For cultivation, rain must be enough and abundant in summer, or it should have good irrigation. Rauwolfia grows well in clay, acidic pH 4 to 6 and well manured soil. Ploughing must be deep, because to facilitating the development of the roots, if it is very soft soil, if you plough in deep. Propagation is carried out by planting seeds. Root culture or stem cutting can also be done, but seed propagation gives better yield of root in spite of the fact some seeds are weak in germination. Therefore, cultivation of Rauwolfia is usually carried out by the seed propagation, immersing them in saline eliminates sterile seeds. Collection: they are collected in October to November after hot and dry period. In Indian pharmacopoeia, collection of roots 3 to 4 years old plants is mentioned, but in culture it is found that roots of 2 years old plants are equally good. For collection of root plants or roots plants are drugs dug out, dug out, aerial parts and removed, aerial parts are removed by cutting, and roots are separated. Roots are washed and dried in air till moisture is about 10 to 12%. Roots should be stored protected from the light. This is the root, serpentine root, Rauwolfia serpentina, snake root. This is the dried one after cutting into pieces. Macroscopical characters of Rauwolfia serpentina roots. External features of the roots and rhizome are nearly similar, but rhizomes can be made out of the presence of small center pith and also having more starch grains. Drug contains of most small pieces, which are 2 to 15 centimeter long and 3 to 22 millimeter diameter. Pieces are cylindrical, slightly tapering and tortuous. Outer surface is grayish yellow, pale brown or brown. Fracture is short. Fracture surface show yellowish to brown bark and dense pale yellow radiating wood with 2 to 8 annular rings occupying nearly 3/4 of the diameter. Odor is odorless. Taste is bitter. And when we come to microscopical character, it's a bark. So we should know that it's a bark or it's a root. Bark will be the root. It is a root. So it will be having a cork cells, cortex cells and medullary rays, and apart from the bark you will be getting phloem, xylem, secondary phloem, secondary xylem and primary xylem. So as I told in the class, it is necessary for the students to know about the general part of a root so that it will be helpful for you to draw the diagram very easily. Cork, cortex, and which you know that cork cells will be a small layer which will be lesions and broken, brown in color, dead cells will be there. Cortex area you should know phelogen, pheloderm, and where there may be pericyclic fibers will be there. And phloem cells you can say primary phloem, secondary phloem, then secondary phloem and secondary xylem, and then comes primary xylem or pith, which you know that it is separate. Xylem and phloem are separated by cambium in a wood or in a stem in a big trees. Cambium rings will be formed separating xylem and phloem. So xylem and phloem, you should know that woody part are having lignin structure. When you are staining with fluoroglycinol, you will get pink in color. So don't forget this general information which I have given in the class. So this will be helpful for the student to draw the diagram with a pencil in the examination point of view. So you can see the parts which I have drawn and which I have shown in the picture is striated cork, pheloderm which is present in the cortex area, starch grains, calcium oxalate prisms, secondary phloem which is present in the phloem region, and then you can see vessels of, because it's woody region, vessels and woody fibers also seen, and wood parenchyma pink in color can be seen, and medullary rays which are very clearly, which we can see medullary rays which is moving with a brick-like structure. So TS of a root present in a circular outline of typical striated cork and other secondary features. Following are the tissues seen from the periphery of the center. Periderm, cork, phloem, not phloem, phloem or phloem. You can say not pheloderm is next cortex area. This is phloem, you can say cork. Striated consists of alternating bands of smaller subraised and unlignified. Unlignified, they will not be pink in color when you stain with fluoroglycinol. Unlignified silk up to 8 to 10 rows in the radial depth. Larger submerized up to lignified cell, but dignified cell, larger subrized with lignified cells up to 5 to 7 rows in radial depth sometimes, which you can see the darker lines which you made. Phelogen, of course, then you can see a indistinct but is seen in a narrow layer of thin walled cells. Pheloderm, which is marked in the picture, 5 to 7 layers immediately below the phloem and cells is arranged in a radial rows, whereas away from the phloem cells are oval and as intercellular spaces which you can see in the picture. Pheloderm consists of abundant starch grains with triradiated hilum. In the starch grains, hilum will be there. So with hilum in the starch, and typical twin prisms of calcium oxalate prisms also present in the pheloderm region. Secondary phloem, a transverse intransverse section or intransverse by conspicuous medullary rays, which you can promptly, we can see that without lignin, pink, not without pink. It can be seen very transparently, brick-like structure passes through the xylem and phloem area. Phloem consists of sieve tubes, compassion cells and phloem parenchyma, starch grains and calcium oxalate prisms occurs through the phloem tissues. Secondary xylem, it is also transversed by well-developed medullary rays. Xylem consists of vessels, wood fibers and lignified parenchyma. The vessel appears rounded, polygonal or at times radially elongated and occurs inner, single or in pairs. Xylem fibers appear as rounded and polygonal structure with thick lignified walls. Typical calcium oxalate or oxalate prism and starch grains resembling those of the phloem in the upper area and phloem occurs freely in the wood parenchyma. Medullary rays very transparently seen in the area of phloem and xylem. It passes through, in the picture you can see, it runs radially from the center of the cortex through the phloem, rays into the xylem region, are lignified, pitted and 1 to 5 wide, although uniserate rays are prominent. In the phloem region, the rays, that means the medullary ray cells, are not lignified. But when it comes to xylem's area, it is lignified. So this type of identification the student can be seen in the microscope. So you know that phloem, then xylem. Phloem area, it will be unlignified. When it comes to xylem area, it will be lignified. In the phloem region, the ray cells are not lignified. Starch and typical calcium oxalate prisms are in the medullary ray cells. Chemical constituents, alkaloids, indole alkaloids, 1.5 to 3% is present. Weak basic indole type of 7, pH 7 to 7.5. Reserpine group like reserpine, racemine, deserpidine. Tri-indolin alkaloids, pH 8, ajmalin group, ajmalin and ajmalisin. Strong basic anhydronium bases in pH 11, basic pH, strong, and serpentine group, serpentinin and alsotonin. This is the structure of reserpine and racemine. You can see the structure of racemine and reserpine are similar, only why it is called racemine, that means a double bond, CH double bond, CH is attached in the methoxy, that is 3-methoxy group, which you can show in a circle which I have drawn in the slide. You can see very clearly an addition of CH2 double bond CH2. That means if you know about cinnamic acid structure, cinnamonaldehyde structure or cinnamic acid structure, then you know that it is ethylene group which may be additionally present. That is why it is called racemine, cinnamine. Reserpine, racemine. Serpentine and alsotin. Serpentine and alsotin. Serpentine and alsotine, you can see the structure is not very clearly, that is serpentinin. They forms the serpentinin. That's what I want to say. They form serpentinin. Just I am pulling down to make you to see clearly. you see that the serpentine and altosinine will join together to give serpentinine. So, a student should know what are the basic constituents. In ajmal group, ajmalesin and ajmalin. Ajmalesin is same indole with a 6-membered ring with a CH3 and COOCH3. But ajmalin is also same thing, but only thing is it has a structural difference from the indole additional group, which you can see how it has been drawn with an OH group and CH2 OH group. The 6-membered lactone ring is converted into an 5-membered with presence of nitrogen. So, uses of Rauwolfia, very important for the PharmD students. Rauwolfia is used as an hypotensive tranquilizer. Hypotensive. It reduces the increased body blood pressure to the normal. And it is a tranquilizer. It is a tranquilizer. It can reduce anxietiness. So, and having an psychotropic activity also. Reserpine being a main alkaloid in responsible for activity and is used in anxiety condition and other neuropsycho or psychotic diseases or psychotropic diseases or psychotic diseases. Sedative, calm down activities and excitement reserpine group, stimulates the central and peripheral nervous system, ajmalin group, and decoction of the root is used for increasing uterine contraction in different causes. Even it is used for uterine contraction. Sometimes to induce the delivery is also possible to use in the olden days. And the extract is used in intestinal disorders and it is used for anthelmintic, bitter tonic to remove the worms. And febrifuge, this febrifuge I told, febrifuge, a plant source which is used for reducing body temperature to the normal or elevated body temperature to the normal, like antipyretic, but it is a paracetamol, is a synthetic, that is why we say antipyretic. But a plant source like a ginger juice which can be also used for antipyretic, then we can say it is febrifuge. So, Rauwolfia extracts is also used for as a febrifuge, antipyretic. So, substituents and adulterants, the following species of Rauwolfia are substituents for genuine drugs. Rauwolfia amatoria. This can distinguished from the original plant or official drug on the basis of scleroids in a microscopy which are present here in abundance. In Rauwolfia canadensis, here again the stone cells, that is also in dead cells or a sclerenchyma stone cells, bigger cells with an pith are present in best, but the characteristic striated cork is totally absent. And Rauwolfia micrantha shows both striated cork and stone cells. These do not contain reserpine and less important alkaloids in small quantities. So adulterants, you can see Rauwolfia density flora you can say, and Rauwolfia perankensis do not contain reserpine. They can be used as an adulterant. They do not have striated cork and stone cells. Once if it is given in the market, the people or the pharmacist will check for its purity and its adulteration. If it is adulterated, then it will be rejected for any purpose. Thank you. So you just listen to the classes. When I come in next class, I will go for, this is indole alkaloids, tropane alkaloids is finished, general alkaloids is finished, and then quinoline we have to come, and isoquinoline also I have finished in the class. So next class we will come to the quinoline alkaloids in a small one drug. So every students have to listen, and so that it will be easy for you to write the exam. Thank you for listening.